So tonight we want to talk about chapter 13. This is a chapter on basically about arrays, but we are talking about more than just arrays. We're talking about how to build a batching application or any other kind of application that might require a matrix or an array. So basically, up until now, we've not talked about anything having to do with arrays, but tonight we are, okay? So this is this kind of programming has been around for a long time. The application that, hang on a second. Yeah, I'm starting. So whenever you're ready, okay. Okay. If you need to get in, if you need to get in the door, you don't have access to the door, right? It's a swipe. It's a swipe. Yeah, you might. Okay. 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 See you. Thanks. Bye. Okay, he's on his way, so we're gonna get to that part of it very quickly. But uh, the idea of being able to control a batch of something is based on the idea of using of matrices. And if you if you've got the idea in your head of like an Excel spreadsheet or an array, you've pretty much got the application as to what we're talking about. Now we're talking about an application that can be used to fill to make a batch of something. Now that's one of the ideas that we have with this, but it's not the only idea. And I want you to notice here that this batching system here is the type that we're talking about, not this type right here. This is more of a built delivery system, and this is not a batching system. It is a batching system, but it uses an old type of technology that basically is hard to control. And it's not only hard to control, but it's hard to initialize and stop. Okay, so that one in the blue is not the one we're going to be talking about. The one in the gray is the type we're going to be talking about, where you fill a main mix tank with one ingredient after another after another. And after each ingredient fill, you weigh that as it's going in, then you determine whether or not the weighment is correct, then you might do something else like mix or agitate or add something else. Excuse me. So that gives you a starting point. Now this is a picture of how you can organize recipes. So you can have recipes that are big, long arrays, and then each recipe has in it steps. And each step then has in it a grouping of words or a grouping of different types of information. The last part of this is the reporting back from the step information back to some file system, which then is kept as a repository for the information about what you're trying to do. So this is a very important step. Why is this important? It's because it's the proof that you did what you said you were going to do, okay? And that sometimes is the most important part of this whole system. And this gets into databases and array handling and basically SQL programming, and that's what is done over at this step. So again, if you are interested in how this works, this is the after the fact going back to the computer from the PLC. This is inside the PLC. This may be in the PLC or it might be in the computer, the head computer. And this is almost definitely in the head in some kind of a computer system someplace. So you have data stored in various places with this. Okay, so now each step, then you have to be able to increment through and move those steps into a working area so that you can do the control. So basically what you want to do is you want to minimize the amount of programming you do to control your process. And in order to do that, you have to basically isolate what it takes to control a step, make that your goal, and then each step sequentially is worked on by that program. So basically, it's a very economical way to write logic. Now, on top of that, you have scale interfaces and all that goes along with the scale. And that's not something that is easily done either. So you have to master that part of it as well. So now we're talking about moving of data around. We're talking about indexing through an array. And you're probably going to ask the question, I've never created an array in a program controller. How do I do that? Well, they both have their peculiarities, and this chapter does talk about how you actually create an array. In Allen Bradley, you just basically declare an array as a data type, and you get, here's our stuff. So we're going to shift here in a second to phase 2. But there's 2 different ways of doing the array. Allen Bradley is basically declare a variable, but then you can make that variable an array, and it's shown how to do it in this chapter. The other part is, this is Ethan, and he's going to help get started. So he's going to tell you who or how you want to do. You want to, what's the 3 projects you want?
Electronics components kits, ULEDs put in each of them. How many people do we have?
Approximately 60. There's 60 people took the test. There are probably 50 people in here. I don't know exactly, but it's between 50 and 60 people. Third, a third, and a third. Is that you want a third, a third, and a third?
Probably.
Okay, so what are you going to pass out? You got boxes that
Yeah.
assemble? Okay. I got boxes to assemble. Where are they at? They're right there? Okay, so how many boxes are there? 300?
There's not two. I don't have all of them here.
You have 7 on this, what we have.
It's probably 30.
30?
Yeah.
So you're just gonna get 30 finished boxes. But you're gonna get all the other stuff put together. Okay, so here's 30 boxes to assemble. All right, so the other part is put the batteries in the voltmeters. You got okay.
Parts kits.
You got voltmeters, okay, so you're going. So okay. So what do they do with these? LEDs. So this is for the LEDs. So this is 70 capacity out, and then each person brings maybe a few of them, and then they're going to put LEDs. How many LEDs?
Should just be 3. 3.
3.
So you need 3 sets of green, yellow, red, and traffic light.
So they need green and yellow, red, and 3.
They're just yellow, right? It has the green.
So it needs 3 yellows. It's each of these yellow, LED, and 3. This is. I want to simply decide how you test these out. You need to open this up, you tell them, and then where's the LEDs? Here's the LEDs. We need 3 LEDs in each of those kits.
There's
So we need to open that up and start filling in the LEDs.
green kit. There's already a little baggie that has the green and red LEDs. Just put them down in that baggie.
And here's the rest of the Detectors are played. This is each one of them gets 3 LEDs, so it's passing out. Where's the LEDs? Okay, is that the only way we got LEDs? It's passing out all each one of LEDs. 3 of them, okay, each person, okay. And you guys are gonna do the boxes. 3 boxes, so you're gonna do. Okay. What else? Weird. Any butter? That's it. To the back of so the moment little I got in my pocket. So this is my So, get it done. Yes. More of these kids. Okay, we've got an inbox of the kids, and he's going to get more screwdrivers so that he can put the meters and okay.
getting to the point where I think you can quite get it. So, if you're done having to do, that's fine, but the done whether it's going, the done gets the money here, the ones that are not done are going to there. Um, I'd like to keep talking about,
arrays, because I think it's an important subject. Okay, can I have your attention? So we use these blocks called blocks of whole blocks of data in order to control the movement of large blocks of data in general. And there is a type of variable called a variant, which Siemens supports, and it basically adapts to whatever type you are wanting at that time. So it's called the variant type. I've not used the variant type, but you can use it in a lot of applications. Now, I'm going to talk about applications here in a minute, but I also want to talk about the idea of, okay, this is a so this shows the creation of an array, okay? Can I have your attention, please? This shows how to set up an array in Siemens. This is how you set it up in Siemens. You have to declare a data block. This is the type of where you store data, and you have to declare a data block in order to get an array. You cannot use an array in the M table. It does not work. Okay? In order to be able to index through an array, you must declare it in this block. So you declare a data block, and then you can address data in that in any format you want, including arrays. So this shows how that's done. And this shows in my program, wherever my program is, now I can access it by using static data in that array, in that data block. Okay? So it's static data in a data block, and that would be the array name, and then the data block name precedes that. And if you address it, you have to address it by the data block. Okay? So in my program, I can write an array, and then I can define it in that data block. So this is on page 12 of chapter 13. In Allen Bradley, if I call up a variable and define it, I actually have the option of adding an array to that data type. And I can have it I can have a three-dimensional array with Allen Bradley. And finally, Siemens did the same thing. They've got multidimensional arrays, but they did not have them until recently. Okay, so either Allen Bradley or Siemens has the ability to support arrays. They have to. This is an important concept having to do with all different kinds of handling of data. Okay, so what is a UDT? User-defined table. Okay, anytime you have variables that you're passing from one computer to another system, like let's say you're a supplier to Ford or GM, and they're building cars. Obviously, they're building cars. You are passing information to them. They are giving you a setup of a UDT, and as you're making parts, you're creating UDTs that then when you pass the parts to them, physical parts, you're passing them a UDT of what those parts are. So everything is stored between companies in these UDTs. It's the same as a data block in a database. So the fields of a UDT are like the fields in a database. If you have an Access database, any kind of a database, there they are. Okay, that's how you basically create the ability to pass information from one computer to another. And PLCs have that ability to make a UDT that you pass information from one to the other. Okay, what does this look like? This is the UDT, but it looks just like the declaration of an Access database to how to create a field or a row of data. If you're not familiar with a database, basically you declare each field and then each row of data, each entry of data has different types, and you declare those, and then each of those are stored as one block of data, like one entry. So each piece of equipment that you would make or each thing that you would declare has various types of data going along with it, and those would all be stored in a row of data, and that would be a UDT. So you can declare a UDT in a programmable controller, you can create the data, then store it in a UDT, and then pass the UDT to another computer. That's how it's done. So I might at some point in time ask you to create a UDT just for the mere fact that you want to be able to say you at least know what they are. What is a circular table? Well, believe it or not, computer systems do not work well with each other. So if you have data being created in one computer, and then that data is being sucked up by another computer and taken by another computer, you need to have some way of buffering the data. So you can be going through and building a file, and then another file, another file, another file. But what happens if the computer that is looking at that data goes down? Well, you can have the circular table that basically takes that data, and then when you get to the bottom of it, it wraps around and starts at the top again. The hopes is that by the time you get to the top again, you recovered and picked up the data that's in the middle. So a circular table is basically kind of like a merry-go-round, and you're picking off the data as it comes around, and then when you are ready to when it's ready to be taken, it's taken, but if it delays, you still have some buffer or some time. It's called a circular table. Okay? Anyway, I want to talk to you primarily about some of the applications that uses this, but I also want to talk to you about some of the older style addressing modes that have been used in the past and are no longer available. So these are some of those types of how you index through tables. And if you're in the United States and you work with Allen Bradley, you might run into some of these. What they did was they basically got rid of they got rid of these with the newer style, the control logic panels. They got rid of them. Is everything pretty well done? Everything pretty well already set? Are you all? What do we need?
This line.
Okay, where are they at physically? Right? There's a bunch. Okay. So there are a bunch of multimeters that are still out. Yeah. Well, go get them. We'll fix them. We'll get them. Thank you. We'll get them. If you got them, we'll take care of it. We got time. Okay. Thank you. All right. So the older style PLCs use some very cryptic methods for indexing through arrays, and we suffered as a result of it. If you want to know some of the things that were done in the older PLCs, if you wanted to make it very hard for somebody else to read your program, you did some of these indexing methods. And I guarantee you, they were only popular with people that like to be cryptic. So what they did was when they built the newer PLCs, they got rid of them. But if you run into some of these, you will at least have an idea that yes, these older indexing methods were used, and there they are. I'm not going to go through them with you other than just tell you that they existed. Okay, so down here is some applications. I want to talk about applications. I also want to talk to you about the idea of how to index through an array. So basically, you have Allen Bradley and Siemens finally agreed on something. They have the name and then they have the parenthesis indexer. So if this is a variable, you can keep moving that number, and that's an integer number, and you can go pick down through an array by incrementing that number. All right? So this is a number that allows you to go position 0, position 1, position 2, down through an array with that index. And that's how you control how you go through an array. And they both do it the same way. Okay, now, this is a scale weighing unit for Siemens. It's very accurate, and it takes a load cell in. It's not a cheap device, but it does the job, and it gives you an accurate weight. Now, this is a load cell. Load cells basically are a strain gauge, and they record weight very, very accurately. So if you put weight on them, they give you if you force down weight, if you put a force on them, they'll give you a weight. And these can be very, 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 very accurate. Now, this is a weighing system that you might not consider a weighing system, but it's a load cell on these rollers, and you're actually weighing the material that's going across that belt on the rollers. And that can be very accurate as well. This is the most accurate, however. With load cells and a tank like this, you can get very, 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 very accurate. 1 part in 10,000 is not unheard of at all. You can get very accurate with it. Now, this is a cheap load cell device, but let me just give you a heads up on this. The older style scale readouts or interfaces updated every 1/7 of a second. Every 120 milliseconds, they updated. This one updates every 330 milliseconds, or about 1/3 of a second. Now, what's the difference between this one and the more expensive one? What's the difference between this one and a very expensive Siemens one? You can be accurate to like 1 part in 10,000 in 10 milliseconds with the Siemens one, whereas with this one, you're only accurate to 1 part in like 300 milliseconds, okay? This updates only once every 1/3 of a second. However, you can do what we call a linear interpolation inside your program controller, and you can build a rate of increase of your weight in your program, and you can predict very accurately where to turn off your feeder with this device. So if you studied linear interpolation and you had that in a course that you took, and you said, I'll never use this in the real world, think again, because this works very, very well. I've done this. Linearly interpolate. What you look for is you look, when does the weight change and when it jumps, if it jumps very much, and then you build a ramp of those weights when they jump, and you build when you can predict in between these readings any place along this ramp, because the feed accuracy is pretty accurate for the most part. This ramp is usually pretty linear. It depends, but most of the time it is. If you got a constant pressure of the device coming in, it works very, very, very well. If you got a variable pressure, it doesn't work as well. So again, you have to know your physical system. Now, here's an aside, and I want you to be aware of this because you're all novices when it comes to certain things, and most of you have never heard of a batching system before. I mean, you may, for the first time, think about it and think, yeah, I know what a batching system is. That's kind of like at a grain elevator or something like that. Grain elevators are not batching systems. Grain elevators look like batching systems, but they're not batching systems. If you go out behind the, over at LOF plant and behind the Hollywood Casino, you see what looks like a grain elevator. That's not a grain elevator. That's a batching system, okay? So what they do there is they store the ingredients and then they weigh them up and then they put those ingredients into the furnace and they make glass. So that's a batching system. So that the idea of how to create one of those things and how to write the programs for it is, it could be lost except for the fact that they built a specification for it back in the late 80s, SP88, which I think was in the year 1988. They built a specification which they basically defined every kind of thing you can do in a batching system. Okay, so there is a specification for this. And where did this specification reside? It resides with the Instrument Society of America or International Society of Automation. Now it's ISA. So they basically have built a specification that tells you how to build batching systems. And they're very complete. If you look at SP88, you can build a batching system from scratch using nothing but reading that specification. You say, are you sure? Yes, they're more complete than anything I've ever seen. And I've built batching systems, and I know that they studied and they've got all of the various techniques and all the various things you can do, and they've got them down and they've got them in very good position. So you say, well, I'm going to tune in the International Society of Automation, and I'm going to look at all their specifications. Some of their specifications aren't worth anything. Their specification on HMI panels isn't worth much at all, but this one, SP88, is. Some of their specifications are worthwhile to look at. So basically what happens is they get together as a group of individuals and they come together and they decide that they're going to write a specification on a certain topic, and this is one of the better ones. Some of them aren't that good, but this one is. Okay? So SP88, batching systems, something that you might someday be interested in writing and saying, now, how would I ever do it? Your boss comes up to you and say, well, we don't have anybody to do the batch house. Are you interested? And you can't say, I have no clue how to build a batching system after tonight. Because first thing you should say is, I'll dial up at SP88 and I'll look at it and I'll give you a clue as to whether or not it's something I want to do or not. Now, honestly, they're fun and they're very interesting, and they take a lot of work to do, and there's a lot of parts and pieces to them, but they're intricate and they're very good programming. They're very good implications to do. I'll just be blunt. They're very interesting. Here's some of the state diagram that they give you. They give you all kinds of state diagrams. This is just a sampling on the SP88 list. So you say, are state diagrams interesting or are they needed? There's an example of a very useful state diagram for doing a specialized function in a batch house. And right there it is. And reports. My goal is to never have to write a report ever in a PLC application, okay? I don't know if that's interesting to you or not. Now, I'll give you a clue. Writing of control programs is right up there at the height. That's the best, that's where the action is, okay? The next level down is the diagnostics programming. So you're writing diagnostics programming, and the HMI is over there someplace as well. So there's three areas that you need to watch for when you're writing programs. The control aspect, the diagnostics, and the HMI. Those three have to kind of go together. But then at the end, you're writing reports that print out what you did or your data, that actually prints out the data. And good, bad, or indifferent, the people that are trying to keep you there and keep you on site, if you're traveling, if you're out of town, they'll keep you there for days because of the period that needs to be moved over one space to the left or the right or whatever. And my goal always was to get the the consumer or the person at the end of the engineer or whoever's in the plant to do the reports himself. If I could get him to do the reports, I was out of there. I could get on a plane and go back to good old Toledo and do this and be done, as opposed to having to sit there for days on end for them to study reports. But somebody's got to do them. So again, I don't want to discourage you on the report side of it, but somebody's got to write these stupid report printouts of how things are done. And that's SQL, that's database applications, that type of thing. If you like doing that kind of thing, you can do that the rest of your life, because that's something that is very necessary. But it's an add-on to most jobs. Okay, so this is more of the SP88 stuff. And then I get down to this one. Okay, now this, you think, what is this? This is a process that I'm not telling you exactly what, or I'll tell you where it came from, but it's not exact. This is from kind of like what the batching system, the liquid batching system in Aiken, South Carolina for 1 fiberglass was at one time. So you have 3 main mix tanks. Any main mix tank can call for material directly, or it can call from material from a premix tank. And each main mix tank can grab any of the premix tanks and grab hold of it as long as it needs it for its batch. Okay? So you got a maximum of 3 batches being made simultaneously. Any main mix tank can call any premix tank. At the same time, it can be adding ingredients to the main mix tank. So you could be, this guy could be adding something here, and it could also be calling up maybe 1 or 2 or 3 of these to be making something for it as well. Write that program and make it work with arrays. It can be done, but it's just, there's a lot going on, as they say. There's a lot under the hood, all right? So as you're asking the question, how complicated can these systems be? Here's a fairly complicated system. It's not the most complicated system in the world, but it is fairly complicated, okay? Does that make sense? Does everybody understand what's going on here? What is this stuff doing, Ben? What is this going to? These are the liquid binder systems that go out to the various lines where they're making fiber for fiberglass. And they coat with this material, and it's kind of like snot. It's a sticky material, but it coats the fibers so that fibers, if they're not coated with binder, will break. But if they're coated, they will rub against each other and never break. And that gives fiberglass its strength. So if you're building a boat, or if you're building a pole vault, or whatever you build out of fiberglass, if the binder isn't right, it could fail. But if the binder is right and is correct, then you've got a good product. So that's got to be very accurate, and they are very accurate. Okay, so what other kind of recipes are there? There are many, but I'm going to go through one of them, and I'm going to talk to you about it now. And this is the Rubik's Cube project, okay? And I'm going to tell you how to solve a Rubik's Cube. If you really want to know my opinion on the Rubik's Cube, this is how I would actually do it. So, and again, all I'm doing is turning to my friend, an array, and saying, let's organize based on something that we know and something that we can actually do. Okay, so this is the text accompanying the weekly projects. And this is, by the way, these projects are the same as the ones that you're doing to an extent. Okay, so if you want to go back to chapter 13 at the end of the chapter and get 4 points, this program right here is one that you can type in and have running. It doesn't take very long to do. You need some help? What? Okay. Who wants to help him get some more batteries? Get these going. He's got more screwdrivers and more batteries. Okay, good. All right, so we've got, did everybody get signed in? Did everybody sign one of these sheets? Where'd the other sheet go? There it is. Okay, so this is the one. Let's get, okay. Let's get, this one. All right, so I'll be talking up here, and then you can get those done, and I'll call back. Okay, sure. But I want to explain to you why I turned to arrays. Okay, why did I turn to arrays to solve this problem? All right. First of all, see, I have not personally solved the Rubik's project. I did not write the program to do it, but I had to do something, and I looked at it from the point of view of how okay, so what I did was I took the tiles and I numbered them. Okay? Everybody follow that? I took the tiles on the Rubik's Cube and I numbered them. And then I assigned colors. Okay, so I put a number in each point in the array, which basically aligns with the state of where that Rubik's Cube, how it comes up as. Okay, so I have an array of. I'll show you how this looks when it's actually. This is what it looks like when it's actually running. There it is again. Okay, so I did this program and gave it away. So basically what I did was the positions on, before they're defined, in other words, if there's not a color in the array in that position, it's black. As soon as I assign a number to that position, it becomes that color. So I have, if it starts here and it goes down, it keeps going. So basically, I start with that one right there, and I key in a number from 1 to 6, and that puts that color in that position. How do I define the present state of the array, or how do I define the present state of the Rubik's Cube? I fill the numbers in an array. All right, there's 48 positions other than the center tile. If you count them up, there's 9 times 6 is 54, but you have the center that never moved. 54 minus what? 6 is 48. So it's 0 through 47 are the positions of the array. And each one of them, when you put a color in it, it turns to that color. Now, what else happens? When you spin the array, when you turn 90 degrees or 180 degrees, you do what? You have to physically turn and you have to reposition those colors in the array. All right? And how did I do that? I wrote positionally, I wrote 6 functions that, and I did 3 clockwise. So if you want to go counterclockwise, you have to do the first 3 columns. You go 90, 90, 90 to get 270. Okay, so I did it that way. And I'll talk about functions next Monday night. But I wrote 6 functions that basically move the colors in the array as I turn these. And you'll see that when I actually on the screen, you'll actually see that. So I used that array to keep track of where the colors are on the physical device. Okay, as I'm turning them, as I'm making these turns, as I'm physically turning this device on the screen, I am physically moving these colors. Okay, I'm physically moving the colors. And you will see that when you execute that program. So I'm physically moving those colors around. All right? You'll see it. When you execute a 90-degree turn, these colors, if it's the green, this one goes over here, this one goes over here, this one goes down there, et cetera, et cetera, et cetera. You'll see it. Easy peasy, right? Okay, that's the easy one. But now, what else do I have? I have with that array, how do I check that array to see that if it's working or not? I have a watch table. And as I turn it, I see the colors moving in the watch table. Okay, so positionally, as I do a 90-degree turn, I move those numbers in that watch table to their new position, and I see that with updating the watch table and seeing it. So I can check it very easily by executing the watch table. So see how you use an array to create control of where you're at with the Rubik's Cube? You follow that? How would you do it otherwise? I don't know. But an array is your friend, okay? And an array really becomes your friend with the other array, which is this array right here, okay? So with week 9, I actually tell them to start programming the actual program to solve the array. But I also, in that same breath, I point them to this in the website, which basically says how to solve the Rubik's Cube, okay? So how do you solve a Rubik's Cube? Well, the first step is the white cross, all right? The white cross is the white cross. It's on top, okay? The white side is the top side, and the white cross is the 4 tiles that are on that side that are white. So the white cross is the first thing you do. So how do you physically do that? Good question. You have to build some kind of logic, and the first type that most people take off and do is what I call cross-field running. They just kind of start, and they keep adding and adding and adding and adding and adding and adding and adding program, and after a while they get to the point where they say, I've got all these move statements, I've got all these move statements, and I've got all these move statements, all these move statements, all these move statements, and all these move statements, all these move statements. And it starts to get cumbersome, and your ability to keep track of them all starts to break down. Okay? So at some point, the scales tip from this looking at each one of them and figuring out what you got to do to get it there, and then doing it, and you say, I got a smarter idea. And the smarter idea is to build a recipe handler just like the batching system, in my opinion. I haven't written it, but I can tell you this makes sense to be able to break down this program into something that's very manageable. Okay, so what do you do? So you build an array. Now, this may sound ridiculous, but it's not. If you define a 32-bit word, can you get all the information in that to basically do a move? Okay? And the answer is yes, you can. Now, I tried to do it in a 16-bit word, and I ran a little short. I don't know how you would do it. This is one way. You can maybe do it a little bit differently than this, but basically what I saw was each one of these 32-bit words carries all the information you need in order to say, make a move, all right? Or don't make a move. So what do you have to do? You have to say, I'm going to look at the colors that are on the tiles where I'm at. In other words, the array number and the color of the tiles. So in other words, I'm going to be looking at a position like number 1 and 33. So 1 and 33 would be see what 1 is, and then on the back side, the blue side would be 33. So you say, is the white green in position 1 and 33. White, green, 1 and 33. All right? If it is, do the move. If it isn't, go to the next one. Does that make sense? Do you see how you can start creating the logic for this by just going down an array? And how many move statements do you have? One. One move statement. So instead of having all these move statements and all this logic spread out all over the place, now you basically crunched it down to an array in a very small program. So again, turning the array into your friend and using it as a recipe can help you in a lot more things than just building a batching system in a factory. You can solve the Rubik's Cube with this. And I'm not saying it's easy, but I'm saying that this approach breaks down a lot of the hard part of being able to do how to code the rest, how to code the Rubik's Cube. Does that make sense? Maybe? Because that's what I've done. I mean, I physically am not going to do it. I'm not going to write the code for the Rubik's Cube. I'm going to just help other people do it. And I'm not saying that's what you should do with your semester, but that's how I would turn that program into something that I think I could make happen in days as opposed to months, as opposed to years. Okay? Where are we at with the stuff? Ethan, are you getting there? Pretty close? Half? Okay, we got about 15 minutes, so you're okay? All right, okay. Do those sheets make it around? Did everybody sign those sheets? Where are they at physically? You got them? Are they all set? Did everybody sign? Whatever happens with the and I appreciate it and points. I also want you to understand that this is the matrix idea is not necessarily the first idea you always run into, but it does help you, okay? So when I was working for Owens Corning, there was a project that I did that incorporated 50 some odd valves. And the company that was working with, they wanted to be able to transfer liquid through those valves. And I basically built a matrix of which valves had to turn on for a specific transfer. All right? And then there were 50 some odd transfer paths. And I built up 56 of these 56 of these matrices, or 56 of them, okay? And you call up which one you wanted, and it would come in and do its thing. And the other way of doing it would just been to code logic, if then else logic across to do that. And I thought I would be better off if I coded it as recipes. And the first day when they wanted to start this thing up, the guy came at me and he said, he had given me 66 recipes. And the one he gave me that day to try out, to start out with, wasn't on his list. And I said, this isn't on your list. And he looked at me kind of sheepishly like, yeah, let's see how you do it. And in 20 minutes, I had a 67th recipe coded and ready to go. And we tried it out and it worked. So again, recipe storage matrix operations is one of your best friends. Whatever the application, if you can put it in a matrix, do it, because it makes things a lot easier and a lot friendlier most of the time. It's just, most people don't think about it, and most people don't have that in their head to do, but if you can, it works very, 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 very well. Okay? So, how many of you are ready to code up the... Oh, and by the way, the other thing about this is those numbers... Now, I'm not saying it's easy to put those numbers in there, okay? So what's going on outside? What's the best way of putting those numbers in there, in those bits? Build another HMI screen that asks the question, what about this? What about this? And it puts the number in and puts it into that spot. In other words, it's hard for you to physically fill in those bits by hand. It's not nearly as hard to have an HMI screen that fills those in for you, much like the screen that filled in the colors of the original array. The best way to do this is to have an HMI screen that fills in all that stuff for you. Let the program do most of the work, and you fill in the data by a screen that actually fills that in for you, as opposed to you having to do it yourself. You having to add up all those bits and do that. This is make it easy on yourself. In other words, if you're going to do this, add a screen. Any questions about that? The other way to do it is to have an RDT thing, and then you can have everything of its own type. But that costs a lot more data and a lot more space in your PLC. And one of the things that I feared originally, now that somebody's done it, I'm not nearly as fearful. But originally, when we started doing this, the first group ran out of memory. Physically, they ran out of memory with the PLC, and they had nearly enough memory to do anything. They just said, we ran out of memory. Well, what are you going to do with that? It's kind of like, okay, you should plan a different way. But I've been very skeptical ever since then of using too much data. And one way of spreading everything out is using every data has a different type and all that kind of stuff. Memory's cheap, but they've got a limited database area in these PLCs. So again, that's kind of where I ended up being scared to death to do. So I cram everything into a 32-bit word, a DINT, D-I-N-T word, and then go from there. Okay? So that kind of gives you a little bit of an idea about matrices. Now, I also, in this book, Lab 6, I'll show you Lab 6. If you want 4 points, and you want to learn about matrices a little bit, type this one in. This is the program for the program. Everybody knows about this, but very few people have ever seen this program work. This is that guy right there. So I've used this for a long time as a entry into indexing through a matrix. So basically, with this program, to mimic that, you can basically build an array, and you can go through different colors. You have to move to a different color every time. This would maybe be one color, the second color, the third color. So basically, one color, two, the second color, third color, fourth color, and it just repeats and repeats and repeats. But you can do this in any order you want to. Now, the only thing about this program is that once you've played it once, you get the idea and you can play it again, and it's the same program. It's the same game every time. So by the third or fourth time, you can memorize it, and it's not random. It basically is it's a fixed game, okay? But that shows you how powerful this idea of arrays is. So basically what you do is the first one is you show just that light, and then he has to push the button, he pushes the button for that, and you let it out to 2. He goes 1 and this, the second one, he does 1 and 2, and then he goes to the third, he goes 1, 2, 3, and then goes to the 4, goes 1, 2, 3, 4. And you let the rope out a little at a time. That's the program that's written there. And you can look at it, it's all given, and you can program it, and you can set up the array, and you can get a little bit of an idea how arrays work, and you get 4 points in the process. And this program works. The only problem with this program is that there is a delay, about a couple seconds delay between pushing the button and it going over to the PLC. So you have to wait. You can't be quick about pushing the buttons. You have to push, wait, push, wait, push, wait, push, wait, etc. Okay? But this works. This program actually does work. One of the few that I did. But anyway. Any questions anybody's got? I'm done. If anybody, you guys want to stay for a few minutes, we can get finished on this, and we'll get out of here. But you can go if you're. I did not grade any more than what was the tests that anybody's not picked up are up here, and the stuff that was graded prior to Monday night is up here. The stuff that was from last that was handed in Monday night is not graded yet. My answer key is right there if you want to look at the answer key. So. Appreciate your time. Thank you. We'll be back normal chapter 14, or maybe we'll go to 19. I'm not sure whether we'll go to 19 next or not, but we need to get to 19 because there's a lot of stuff that I can talk about there, and there's a lot of labs you can do in that area. And there's 8-point labs there. Everybody got stuff? Where we at? Thank you.